Today we're going to have a presentation to you about MDIS, which is an oil and gas companion standard for OPC-UA. So let me start, and maybe I'll introduce myself a little bit too. So I'm Paul Hunkar. I'm a consultant. I work primarily for Yokogawa, but I also work for the OPC Foundation. I'm knowledgeable about most things related to OPC-UA, and I'm the editor and one of the key contributors to the MDIS standard. So what we're going to show you today is provide an overview of MDIS, which I'll present to you, including a little bit of history. Then afterwards, we're going to have presentations by Daniel from Equinor on project-specific feedback, also from Frank and Siemens Energy on their feedback on projects. And then lastly, Markus from Subsea will provide some feedback from the Subsea point of view. And Markus will also include a demonstration of his server. So with that, let's get started. MDIS is an oil and gas standard. It's for interfacing the topside controls and the subsea systems and allowing communications between them. There's typically multiple vendors on a platform, so this communication is a challenge. You have to make sure that the integration works and that it's easy to do. What started MDIS is operating companies wanted a standard communications interface between them, between the subsea gateways or a master control station and the DCS system that sits on the control platform or on the platform. MDIS stands for MCS-DCS Interface Standardization. So sort of the gist of the name. There was a lot of operating companies involved in this at various points in time. Pretty much all of the major DCS vendors have been involved, and also most of the major subsea vendors. Many of the operating companies are requiring MDIS model in the current releases. The goal of MDIS was to reduce engineering and testing costs and also update to a modernized information model. MDIS has been around for a while, been working on it quite a while. The first beta for this model came out in 2015. We tested a number of servers in an interoperability event. We had a second interoperability event with final models and subtypes. Then we actually released the first version of this back in 2016. Since then, we had an update in 2017 that added more certification and checklist items, things that we found we could improve. We had a second or a third release in 2018 that added additional objects, redundancy discussions, valve profiles or signatures, and an exchange format for them, so how we can actually exchange them back and forth. We had a further IOP in 2019. This was as much a demonstration as an IOP of MDIS, and we had our first certified products at this demonstration. So what we're currently working on right now is there's multiple projects working on it, which you're going to hear about later, so I'm not going to spend much time on that. But we have a 1.03 release that's due out later this quarter. It's basically updates based on project feedback. So some of the feedback that you'll hear about, we're using this update to enhance things. We've also added some more object types. We've also defined the valve profile signature stuff, and that we actually have file formats now to exchange that data. We've also standardized more of the errors and warning codes that you can get back. So let me give you a quick summary of what MDIS is from an information model point of view. MDIS supports two architectures that are common in the MCS-DCS world: the gateway profile and an interface profile, so integrated and interfaced. One gets more data through it. One gets the subsea system does a bit more of the work, so it's more for monitoring a little bit. But there's two different formats, and the primary differences is the amount of information being shipped between the two as far as the interface is concerned. We have a fairly large set of or full-blown information model that we built for MDIS. It includes aggregating objects. It includes a large number of object types, data types, variable types, even references showing relationships between the methods to perform actions. We're going to run through all of the object types fairly quickly here. So there's a discrete instrument type, there's a instrument type, there's a digital instrument type, there's a choke, which is there's also electric choke that's available. Electric chokes and and even the valves all have interlock capabilities that are included in the model, so you can see who's blocking or locking access to these devices. There's valves. Valves have the signatures and profile information on them so that we can actually see if the valve's behaving as it should be. Um, the details of this model, if you're interested in, are all in the spec. Part of what the model also includes is interactions for all the methods and how functionality should behave. So if you're moving a valve, what should happen, what variables should change, what objects should be updated. We have in this newer release, so these are not public yet, but we'll share it here a little bit. We have a CIMV object. So it shows the chemical injection valves and what capabilities they have. We've added a motor control, which is really a general way of being able to stop and start pumps. So this is a additional new object that we've added in. We've always had an aggregate object, so a way of generating objects that you don't have in the model. So you can take the existing instruments or various types and arrange them and create a new aggregate object type. We also have a bunch of sort of minor objects that are out there. We have some for time syncing if the servers don't have time syncing. We have a counter object that we can have a reset method on. So if you need to reset counters, you can use this counter either in an aggregate object or directly. We have a base information object that sits in our server. It provides the version you have. It also is a folder that you can organize the signatures, valve signatures on. So you have a way to go find the signatures that are available on the device. MDIS also describes redundancy and how redundancy can be deployed and how the options and how it should be used when you're deploying redundancy. We have OPCUA supports the concept of a node set file, which is an XML representation of the information model in the server. MDIS utilizes this to help alleviate some of the testing and headaches when you exchange spreadsheets or other forms of data that you have to then import in to adjust the configuration on the other side. So here you can electronically generate the export of the configuration of a server, use tools or other things to import it into your DCS system and generate your configuration automatically. You don't have to worry about transcription errors or anything else. So it's a big benefit for automating the testing aspects. We have a section on recommended practices, which describes how you should deploy this. And this is as much to help operators also in what they need to spec for procurement and other items. We have a full certification program for MDIS. So it includes third-party testing by the OPC Foundation. We test not only conformance to the OPCUA standard, but also conformance to the MDIS specifications, the objects and interactions and architectures. All the defined profiles there are defined for MDIS. Functionality in OPCUA is always tested according to profiles, so what's been defined and what's not, and it gives us a sort of overview. The test cases were defined by MDIS, so it includes the full list of test cases are published. And what you end up with when you're done is you get a certification logo that lets you see that this product is certified. So the key thing here is there's an automated setting of testing available for all MDIS products, both clients and servers. Server part we've been running for quite a while, clients a little newer. But the key point is that it's available, and it's a way to assure that you have a well-tested product that you can assure that the multiple vendors will all have the same sorts of products. With that said, I've given you a very quick whirlwind tour of the technical overview. If you have any questions, please feel free to answer or ask them. You should see a question dialog box in your webinar tool. That's where you can type in questions. We will answer questions at the end of the session. We'll open it up for questions, and any of your written questions we'll try to answer. You will get a copy of this recording. Everybody that registered for the event and attended the event will be able to obtain a recording. Give us a few days to send it out, but we'll generate the recording out and send it to all attendees. With that, I would like to pass this on to Daniel, and we'll let Daniel present. Daniel?
Sure. Thanks, Paul, and good morning, everyone. My name is Daniel Abicht, and I'm the leading advisor for Subsea Controls. Why are we so interested in MDIS for us as an operator? And that is obviously because we do see some benefits here, especially when it comes down to, of course, the standardization part. And the interface standardization for us as an operator is quite central. And historically, as Paul mentioned, there have been challenges between the Subsea control system and the safety automation system interface. And we do believe strongly that these challenges can be overcome by standardization, and that was one of the drivers, of course, to set MDIS in place. So standardization of the protocol on the interface and the information to issue for an object is central here. And with that, we are enabling a very clear interface description. And as a result of that, we are able to split the responsibilities, the technical responsibilities between the control system supplier and the safety automation system suppliers, but also the contractual responsibilities. So we do see a simplification on the contractual side, on the contract handling side, because the scope of work is clearly defined, which at the end also simplifies the testing and fault tracing if needed. Midterm, or from a more strategic viewpoint, we do see an increased flexibility when it comes down to system upgrades and future tie-ins, because that will make us a bit less dependent on the previous subsea vendor, and we can enter a more competitive area. As Paul was into, there is a third-party verification possibility, and that helps us to also assure quality, because that the third-party verification is an independent one, and it reduces the uncertainty when it comes down to implement this type of solution. As a second major point, we do see also that the MDIS, that is, let's say, a medium to long-term target, though, will increase the general competence availability across a portfolio of projects. I'll come back to that when going through our, let's say, project examples. We do have still a way to go here, but we do see a potential. So how do we implement MDIS at Equinor? So at Equinor we do have something called TRs, technical requirement documents, and we do have one TR. It's called the 3037, describing the integration of subsea controls and SAS, stating that the technical interface between the SAS and the subsea production control system shall be based on the specification OPCUA, the MDIS companion specification. So we require MDIS in our TR 3037 and are applying it on all projects where we see this is feasible. In more detail, we do specify MDIS as an integrated solution. And the background for that is that we want to have a uniform HMI, and then all HMI functions are located in SAS. We have implemented MDIS in a few projects. I'll pick 3 of them as examples. I will speak more specific about the Johan Castberg, Snorre expansion, and Victus boosting. But we do have MDIS implementation ongoing in Johan Sverdrup phase 2 and a few other projects. The companion spec contains an introduction to MDIS, introduction to UPC UA, and it shows the different architectures. As mentioned, we are looking after the integrated solution as a base case, and the companion spec also contains a description about the different object types as Paul was into. So how do we split up the scope? Just very brief. I don't want to go into all the details here, but that is part of our TR 3037. It clearly highlights the function, right? And then it shows the scope for the SAS supplier, and it also shows the scope for the SPS supplier. For the SPCS supplier. So a bit more concrete on the project side, Snorre expansion. Snorre expansion was a project where we did have the hard and software for the subsea part delivered by Technique FNC, and the topside safety automation system is delivered by Siemens. So here you see the setup. You see the client, the server setup. Both client and servers, they were industrial, or they are industrial PCs running MDIS. This is to handle the heavy load, and both suppliers, they were selecting the same type of industrial PCs, both for the server, for the MDIS server and the MDIS client. So what's the feedback from Snorre? So in general, during the project execution, there was a good and constructive cooperation across all the parties involved. This I think we also see as a result of the clear scope split. But what we noted during the project execution was that the standard that was the previous release, though not the 1.03, could be misinterpreted. So there was a need to improve the precision. We had one example which is now covered related to the CITV. We also see that the companion spec competency across the industry still is not it's not at a level where we would like it to have, but we do see an improvement. But still, this is something we see under development. And from a, let's say, project execution risk viewpoint, we feel that the early simulator delivery from the, let's say, system, from the subsea system supplier to the SAS supplier really helped to de-risk the project. When it comes down to operation and commissioning, a few feedbacks here. So first, this project has been set in operation. This seems to be robust and stable. It's operating, so we are producing. A few improvement suggestions which will be handled by the MDIS working group are in relation to simplifying the MDIS engineering workstation human interface. And this is to enable service engineers and operations to do minor adjustment fault findings if needed. We also feel that more detailed historical data logging should be standard. And we also see that not all subsea tags are used in MDIS and SAS. So we must be better in evaluating which tags should be, let's say, rather rooted to a historical database for support during fault seeking. If you move on to Johan Castberg, Johan Castberg is a project still under development. That is a hard as a subsea hard and software delivery by Arco Solutions, topside SAS by ABB. So Johan Castberg, as you can see here, is having two subsea gateway server units consisting of 4 MDIS servers each. And since this is a project under execution, just a high-level feedback here as well. Across the parties, there has been and there is a good and constructive cooperation. But we see that to implement MDIS has been more time-consuming than we did expect. So we are not sure, but this may be a first-time effect, which we will be able to reduce in the future, I hope. Just then from a timeline perspective, we had one challenge when we had to replace the original interface card due to performance challenges with an industrial PC that required rework and a new let's say certification. And resulted in schedule impact, which in the bigger scale did not impact the let's say entire project schedule, but it was impacting the delivery of that sub package. Then in November last year, we started the controls as IT. About a month later, found that there were significant communication delays on both commands. That was mainly due to the high load on the PLC. The Subsea gateway interfacing the MDIS server, and as we speak, we still have optimization work ongoing. So, but we are still, of course, optimistic that we'll manage it together as we are collaborating in a good way, and we'll make it a success together. Victus Boosting, that is a bit of a special project, I would say. Victus Boosting is a subsea processing project. The subsea processing control system has been delivered by OneSubsea, and the topside safety automation system has been delivered by Siemens. And as you can see here, the interesting thing is that the MDIS server here from OneSubsea is interfacing two independent MDIS clients, one on Snorre A platform and one on the Snorre B platform. And in addition to that, that was the first time, probably was the first time that let's say the MDIS has been used for a Class 2 system. We sort of had to make that decision due to schedule and constraints on the supplier side. We would have liked to have an an integrated solution. But okay, for Victus Boosting, that was the most practical way forward. And again, it was the first time we used MDIS for a subsea processing facility. It was probably not originally intended for this type of application, but because of the scalability, we just felt that this was a possibility. Yeah. So here again, the original interface card did not have the sufficient capacity, and then was requiring us to make software changes in order to reduce the response time, in order to fulfill the requirements for the application. The final solution here gives typically a 2-second delay. Okay, so the interface though between the two topside facilities, Snorre A and B, that works very well. We do have commissioning activities ongoing as we speak, and are planning a startup of the system in April 2021. So my final slide, I would just like to give a brief update on the MDIS inclusion or status on the next API revision. So as a base case in today's API 17F revision 4, there's a requirement related to MDIS already, but we would like to make it a little bit more firm in the 5th revision. So in general, we kicked off the API 17F revision 5 work in March last year. It's of course a bit more than just MDIS. We defined several sub packages, work packages. One of them was to propose an improvement proposal related to MDIS. So we did that in May, and then the MDIS group took that on board in a very professional and very efficient manner, and delivered a proposal which has been endorsed by the working group already, and now will be implemented. That let's say the fixed part of MDIS will be part of API 17F, and let's say the parts which will have to be a bit more flexible, so to speak, because of the let's say shorter revision cycle, they will still contained in the companion spec. So we are working on that as we speak, and as some of you are aware, the API process is a bit time consuming because of the amount of participants in the work groups and the feedbacks to handle. So we are targeting a publication at the end of the second quarter in 2022. Yes, I think that was pretty much all I had to say. So I think I should hand over to my colleague from Siemens, Frank Nolting. Frank, are you there?
Yes, I'm here. So I will try to take the screen now. Thank you, Daniel. Okay, my name is Frank Nolting. I'm working in Siemens Energy in Norway, and we have worked with Subsea products for more than 25 years in Siemens, and we both deliver Subsea equipment like power grid, the connectors and sensors and so on. But in this case, I'll talk a little bit about our topside integration, that we do quite a lot of integration of Subsea equipment from our colleagues, for example, Subsea, TechnipFMC, or Aker Solutions. Siemens Energy have been involved in MDIS from day one, and will continue to back MDIS and use MDIS as a Subsea protocol for interfacing Subsea equipment. In the next 8 to 10 minutes, I want to tell you a little bit about our experience and approach to MDIS and our first projects. I will talk about the MDIS client, as we are, in this case, we are the DCS vendor, and how we integrate it. We also have a small server that we're using on our Subsea modules, and I'll just mention that brief in the end. This is a simple, very simple topology of a typical DCS, distributed control system, or SAS, as somebody mentioned, call it, safety automation system. But in the middle, we will see our SCU, a Subsea control unit. Daniel mentioned about integrated solutions, and that's what we normally will call a class 1 node. That means that it's fully integrating and handling all controls. I've discussed MDIS with a lot of people during the years, as MDIS has actually been around for more than 10 years, so it has been quite an exciting journey. But there can be sometimes some confusion, because when I talk to some people, they believe that MDIS is actually from a topside node down to the Subsea equipment. And it's just important to notice that MDIS is really a topside protocol between two topside nodes. In this case, the server, the MCS, a gateway, and the client, in this case, the DCS. So that's just important to notice, that you don't go down to, for example, the SEMS or anything to Subsea. Siemens have delivered now 3 projects from our colleagues in Stavanger, and that's 2 with integrated and 1 with interfaced. And Daniel was briefly touching them, and that was good feedback for Siemens and for the projects. This view that we see here is when it's integrated, the Subsea control units is handling then all controls, shut down, everything, actually, more or less. It's then we talk, and in MDIS we call it a gateway. How the gateway or the MCS will communicate to Subsea is actually independent of MDIS. So actually you could make a system where you're communicating Modbus to Subsea, and then you're using MDIS topside. So upstream it is MDIS, and Subsea, actually that's independent of MDIS. When we started working with MDIS, we saw that MDIS is very much more complicated than the normal protocols that we're using, but it also have a lot of benefits within this. And the way we solved it in the end was actually that we combined our high-end process control system with a Siemens IPC, the one Daniel's also mentioned, used by a lot of the Subsea vendors also. And when we pair them, we call it our MDIS SCU, or MDIS Subsea control unit. Be able to use a lot of other protocols, but in this we are focusing on MDIS. We combine it then for our IPC. We have developed various tools also, as Paul mentions, for the node.set file we get from the server side. We can parse it and then we can import it into our MDIS SU and then use that for the basis for the generating code and so on. So this is actually, we think this is a very strong combination. It can handle very high loads, and it's very flexible for us. So that's why until now this is our preferred solution. There is where actually DCS meets like MDIS or meets Subsea. There are some things that we need to take into account as a DCS vendor. Working with a SCU as a class 1 node, we often, like everybody else, maybe in the DCS side, working with control objects, HMI objects, and we collect them in what we call libraries. The libraries is actually what we use to build applications, and if we can standardize a library across Subsea vendors or products, it's what we call reuse or standardization. For many years, it have been very difficult actually to standardize this because there have not really been a common standard as we have now for MDIS. When we design a library or a product or project, we often will have Subsea vendor specification. We will have the operator technical specifications. As Daniel mentioned, we will have HMI requirements so that even though that on the platform it's different products, but it will have the same look and feel. We also work with what we call NORSOC. It's a Norwegian standard that we use for documenting things and how we program. And we also then have on top of that the MDIS companion spec. So somehow the DCS vendors need to let these requirements meet. And as you just see here in this simple picture, that when we make a library, we will go through a lot of firm testing, internal testing, FAT testing, EFAT testing, offshore and commissioning. And when it's first commissioned and released, it's not that easy just to actually change it, because then that will do a lot of rework. And a lot of our cost normally and time-consuming factors is actually related to rework libraries, because the next project was standard but a little different. So that makes that we have to revisit all of this. So that's what we are aiming at. MDIS should help us with. In this picture, I just wanted to show you a simple valve interface that we have used. Here we have it's in Norwegian, but anyway, this is what we call arbitration. Here we have all the pressures from A side, B side, arbitration. We have a lot of different things, and so when all this is pre-tested, this is actually locked more or less so that the operators, independent on which he chooses or what, he will know what he will meet also in a stress situation. So it's important to know that we cannot just introduce a lot of new errors. If somebody would like a lot of different errors or something on a valve, it's not that easy, because the operator, even though in a very stressed situation, he needs to know how to react and how to react to things. And that can maybe not, but that can be a small challenge when we are working with this. In Siemens, we have of course gone to MDIS. We have implemented the different object types. Some of the new types like CMIV we are just working on. We are not come to that part yet, but we will work them while the companion specs are released. When you work with MDIS as a DCS vendor, you will see that there is a lot of mandatory items. That means that that's item that the server has to provide to us, but there will also be a flexibility in what we call optional items. The optional items the server vendor can choose to use or not to use depending on his application or fit. But as the DCS actually should be able to cope with all kind of applications, our approach have been to incorporate all mandatory, of course, we need to have them, and all optional, so that we are able to connect to it. Doesn't matter how actually the Subsea vendor, what he will give us, we will be able to cope with most of it, all of it. For the DCS vendor, of course, it can be different from the operator, but one of the things that's very keen and very unique for us is what we call a tag ID that's found in the base object in MDIS. And the tag ID is a unique ID that actually help us connect to the different objects. The tag ID is used in our documentation. And when we see here, I just write in the left corner the NORSOC, the NORSOC standard. In that, NORSOC does not, for example, account for aggregates, so we have to make it a more flat structure when you get into the control system. And on all our documentation, the tag ID will be presented. In the picture you see on your right is actually how we present a well in documentation, how it's interconnected, related to cause and effects, shutdown, everything. This is a way we in Norway use to document our software. So we have just to bear in mind that aggregates is not really something that actually was thought when we thought about NORSOC. So we have to actually bend the system so that it fulfills everything. As Daniel mentioned, we have had 3 projects, small expansion, Subsea, small expansion bundle, and the big booster pumps, 2 integrated, 1 interfaced. Both are now installing offshore. And of course, we have had challenges during the projects, and this is a learning curve we have. We have adjusted our software and parsers and so on, so that we can fulfill the ongoing challenges that have been. We have what we have seen is actually also, as Daniel mentioned, rapid establishment of communication. It has shown that the MDIS we have is very stable and robust. We have event-based communication, large capacity. We have the client-server solution where we have the ability to run both multiple clients or 1 server. We are moving towards now standard, where we really have can reuse libraries and so on, and it's object-oriented. On the other hand, we also have seen that the topology and the data exchange and so on is getting more complex, and then we need to make sure that our engineers have the more competent, the competence about the MDIS. We have seen that MDIS includes such certain freedom, for example, that it's possible to define alarm and warnings, interlock placeholders on individual objects, and that can actually then be difficult, as I showed you before, difficult to standardize. So that's something that we are working on also in MDIS. As Paul mentioned, we are trying to standardize some of the alarms and warnings so that that's easy to implement. Again, aggregation, I can see that it can be very neat and smart when we work with objects. We can collect them for a subsea when that's easy, but on the DCS, it might not be that easy. And then about reside, where functions should reside, there we have used the definition by Equinor in the TR 3037 that Daniel showed, and that have helped us very a lot, and that's, I think that's how we can move towards standardization by defining it. The last thing I want to mention is the client certification. It's just been a little more difficult for us on the client side. That is now an ongoing process with the MDIS group, and we're working on it, and very soon we will have some so that we can easily standardize the clients also. Just an quick revisit to something that I wanted to talk about is that when we introduce new subsea protocols, often we will be also accomplished and acquired to be able to put our subsea nodes into an onshore simulator, process dynamic simulation of the subsea process. And in that case, we're not able to bring in MCSs and all this kind of equipment. We only have the node. So in that case, we have also acquired for that in our solutions so that we can put it into an process model. And the process model does not know MDIS and use MDIS, it uses DA. So we had to make some kind of built-in application to make sure that this can happen. So when we now in the future will use MDIS for our projects, we are able and ready because we have this the simulation part already built in native. And we think that's also a big benefit, because then we don't have to reinvent that from time to time. So that's pre-finished and tested. So in the end, I just wanted to highlight you a little bit of how Siemens looking at the future and how we're working with MDIS and our systems. In Siemens, we believe in an open, transparent, Ethernet-based world, communication also to subsea, with no interruption between subsea and topside. So we have actually used MDIS on we have some what we call digigrid subsea, that's I/O directly on the seabed. We have our power grid, and we have built in MDIS servers on all of these. also alongside with Profinet and with the ProfiSafe, so that we have all the benefits of the different protocols right on the seabed. And that actually enables us to use the same tools topside, program it, document it in the same way as we do topside. That's no different for us if we are going subsea or vertical or horizontal. And we are also able to use really seal-rated I/O subsea from topside, actually encapsulated for subsea. So that means we can really run safe applications. And one of the benefits also is that when we use these kind of applications together, we can actually go down to the 10 millisecond area, even on long step outs. That means that we can do like anti-surge, closed loop, and so on, really subsea from a topside high-end, of course, controller. In the architecture here, then we are using MDIS for its very big benefits. We have our MDIS client also topside, and we can use other clients can also request data from the different subsea objects, and either for cloud, historian, whatever you will use it for. So we are then opening it up for everybody. This is how we work with it at the moment, and that's how we have integrated it now. We have directly I/O for process control and so on, Power Grid. And we think that's maybe also a part of the future, that why should MDIS actually only reside topside? We can just deploy it to the equipment subsea. That's actually it for me. Thank you for listening. I will now give the next speaker. That's Markus, our colleague, Markus Koenig from Subsea in Celle. So please, Markus.
So thank you, Frank, again. So my name is Markus Koenig. I'm senior software engineer at Subsea in Celle, which is part of the Schlumberger company. And I want to focus on technical benefits and give a little live demonstration when I'm talking about the experiences we made with MDIS. So, first of all, a big advantage we are facing is that the collaboration of the DCS and SPCS suppliers leads to a better reliability. So we talked about the interface establishing a sort of standard. There's also a certification process. So we have automated tests, which are OPC-UA specific, but which are also MDIS object specific, that are showing reliability. On the server side, of course, we have more automated tests, which makes the certification process much more easier. And we already certified our server that is running on an MCS, so on an IPC. The second point that increases the reliability is the recommended practice. So we have a roadmap how to design the interface, and we have a list of points that have to be cleared up between each other, what everyone should do, so we can satisfy the needs and be awake on everything. The next benefit is the human readable and browsable interface. So you don't see the data as just a list or an array of values, but also you know what you are seeing. We have data controllers and status elements within the interface, which show what the purpose of each element is. And finally, MDIS and OPC-UA are an independent solution, platform independent solution. So the collaboration between each DCS and SPCS supplier is possible without any issues. From a technical perspective, OPC-UA provides a lot of interesting features. One of them is the encryption of connection. which makes it possible that we can develop and test our interface online. So we, during the certification process we made, or during first project planning, we already were able to put a server online in the cloud, so we can test against, for example, Siemens, as we did, or others, and already check the interface. So this makes the development better, because we can find out issues quite earlier. And also, if you think about today's times, we have Corona. Lots of people are in the home office right now. And if you are able to have a secure server online that allows only specific clients to connect with, you can do your work online. Also, this reduces cost in a way that equipment doesn't have to be sent to the DCS supplier, for example, to test against, and also personnel don't have to travel. So this reduces this cost. So you have you can change and online everything. The second thing that we think is good is the file transfer. So in previous solutions, for example, you have to use Modbus or OPC-DA, and then for file transfer, you have to use FTP, for example. So now you got a solution that completes everything. We have the advantages of object-oriented modeling, such as aggregates, which means we can encapsulate data, we can reuse data, and we can tag data. From a technical perspective, is also the point that the interface is sort of a living process. So of course you can specify as much as you want. But for example, if you want to add one instrument or remove one instrument from the interface, is an object-oriented solution. It is way easier, because it's just one change, and you know, for example, if you remove one instrument, you have removed it from all wells, and you don't have to remove it from every well itself. So we think that the interface testing is reduced, or we reduce the interface testing in this way, so which is a good thing. And to look ahead, we think MDIS provides future specific development. For example, if we want to invent new products like electrical valve or whatever the future brings, MDIS is capable of doing so, and also the maintenance of subsea products can be included in this development. So right now, I want to show you a little demonstration of what I've talked about. So is the laser pointer. So we see here an example of a well. For example, you have here on the left-hand side an annular swing valve, and I will show also a little bit of a DHPT instrument, but also and now we switch to the standard OPC UA client. Oh, I disconnected right now. So this is a off-the-shelf product from Unified Automation, so no specific client from the any vendor, any specific subsea vendor. And now I first demonstrate the connection. So for example, if I have here the properties, currently the security policy is basic 256. And for example, if I choose the wrong policy to connect and I try to connect it, then the connection is removed, and you also got the error message that the security policy none is not supported. So I changed the security policy again to basic 256. And now I connect. So the server certificate is not supported now by the client, but this is just a warning issue. So in the end, now you see the whole interface. As you can see, here's the project where you can connect. Below, there's an address space where you can browse. Below that, you have a log file with the messages, as I showed before. In the middle of the screen, there's the access view where you can see the current values, and it's browsable. On the right side, there's the attribute values where you can see the attributes of the selected element and also the references. So coming back to the address space, we are seeing now that the objects are listed here in the objects folder. There's the MDIS information object that contains the MDIS version and the signatures. And in our Subsea world, signatures are also called profiles, just as a reminder. So if I'm talking about signatures, I mean valve profiles, for example. And here is the base folder of the project. And here you see an example that I've shown before. So I want to show now the instrument, the DHBT1 pressure transmitter. As you can see, it has a lot of information like thresholds, like high limits, high limits with the corresponding set points, and also a process variable. This is an which has some properties, for example, the U range. So you can define for any analog variable, you can say, okay, the allowed range is, as shown here, from 0 to 1100. And also you have an engineering value, so which is here bar. So from the interface, you can already see here that this process variable has a value of 500.123 bar. So the next thing I want to show is the signature, so the profile generation. So I switched to the unused wing valve, which I mentioned before. And as you can see here, we have a move method with this icon. But first I want to show here, you have a reference on the previous signature, which I generated. Now I have the move function. I can call it via the interface. Now we have, since the valve is closed, I want to open it, and we enable the signature generation. And I start the function call. And as you can see, it succeeds. And now I switch back. So the valve is already opened. As you can see here, there's the signature is not yet available. So it all takes a few seconds until it's completed, which is now. Okay, and then we can switch back to the view, and you can see that the timestamp here of the signature is has been updated. And if we go now to the signature, you can here see the new signature, and from this section you can download it. So the last thing I want to show is a fault insertion. So I'm now inserting a fault in the system, and now if I try to move the command back, I want to close it. It is blocked with a message, bad invalid state. And as you can see here, the defeatable close interlock is true. So something that interlocks the valve movement condition has been activated. And if you go to the non-defeatable close interlock, I see in the references window that there are lots of conditions where this interlock is active. So now I can browse on. I go to the access view that I prepared, which has these interlocks, and here you see I put the ROS in control, but for controlling the valve, the DCS needs to be in control. So in the end, I am removing the condition by taking the DCS in control. And as you can see now, the condition is false again. We have no interlocks active. And finally, we can close our valve. So, which is done now. So that was what I wanted to show you from the technical point of view. And as a summary, we appreciate the advantages that MDIS brings, and we try to promote MDIS, bring MDIS to the products we deliver for interface design, because we have the advantages that we have the online server for testing, and that we have the more modern way of interface building. So I hope you liked this presentation, and now I pass back the command to Paul. So
Thank you, everyone. Thank you, Daniel. Thank you, Frank. Thank you, Markus, for all a great set of presentations. Now we enter our question and answer session. At this point, if any of you have questions, feel free to ask them. We will let you guys, we have some questions already in our presentation or in our chat box, and we'll go run through and provide answers to those. So let's start with maybe one that I can answer. Are there hardware-based OPC-UA solutions that have comparable performance to PC-based solutions? Is there a map of throughput performance comparison gap? That's actually a very good question. I haven't seen anybody run studies. Remember, OPC-UA is, you know, a standards body. It doesn't, how should I put it? We don't specify, you know, what vendors produce. So we'd have to be comparing various vendors' products. That said, the other thing to note is that, you know, a PC, typically the OPC-UA application is one of the primary applications on it versus on a PLC. Many of the PLCs use the OPC-UA as a sort of secondary communications. They have their control applications and their built-in communications for their control applications are primary. I have seen some very high-speed PLC solutions running OPC-UA. I have also seen some less performant ones. So it depends on the vendor and what's there. I know that the OPC-UA FLC activity that's going on, so the new FX specifications that'll be published are targeting making OPC-UA the primary communications between PLCs, and that should improve much of the internal communications, but that's to come out later this year only. Let's see, we have a question on safety. I don't know, Frank, do you want to answer this one partially? There's in applications where safety functions are required, i.e. IEC 61508 and 61511, are their devices certified or with enough information to ascertain certainty, such as full loop performance? I think that's enough. You're getting it. It's a question about safety.
Yes, yes. As today, MDIS has not focused on safety loops, and we have not, that have not been the focus on MDIS today. So I just wrote in the answer that when we do this kind of thing, we will use alongside as both MDIS and Profinet are Ethernet based. We will then use Profinet with Profisafe on it to ensure that the full integrity of the safety loop. So as today, MDIS, that's not the focus point of MDIS, has not been as today. So and then when we do this Profinet, then we don't have the IPC anything in between it. We only have the control and the IO card in the end. So
if I can fill in, Paul
Sure.
and Frank, I think just in addition to what Frank just said, I think it's important to separate between production control and process control systems for subsea. From a subsea production control system viewpoint, there is no need for a safety protocol, and this is because safety functions are implemented in a de-energized to trip way. So that means that you essentially cut power topside, and then the system subsea goes into safe state via, let's say, a mechanical spring return. So that is independent from any software or electronics, right? Whereas, and Frank was into that, if you look into subsea processing applications, so there may be a need to realize safety functions in a different way.
And a quick follow-up to that too is OPCUA does have a safety standard that's published. We haven't used it for MDIS at all, but it allows OPCUA to be a black channel for safety communications. I'm not an expert on that, so I don't know much about it, but it is out there. You can find it on the Foundation's website if you are interested in what OPCUA can do for safety. There's another question here that I think maybe for Daniel to answer. Were the experiences made with MDIS so far in line with Equinor's expectations? So,
yeah, in the big picture, they were. As I mentioned, there was across all projects, there was always a good collaboration between the different parties, right? Between the SAS supplier and the control system supplier. So that was all okay. But on some elements, Snow, for example, there was we found that the specification was perhaps not clear enough. We found that the performance requirements were not met on Johan Castberg. It's these things which we sort of book under. Can we do that under technology implementation lessons learned, which we will very likely not experience in the follow-up project. So the big picture, yes, we were happy. That was in line with our expectations, and in the longer run, we do see, we do expect an even more efficient project execution.
So maybe as a follow-up question to that, almost, what are Equinor's future plans for MDIS? So you touched on it, I think, already, but I'll let you answer.
Yeah, we are as all the other companies having joined in MDIS, we are fully in support of MDIS. We are supporting the let's say global adoption through API 17F. When it comes down to project implementation, we do have projects under execution utilizing MDIS, for example, Johan Sverdrup phase 2. And in our early phase portfolio, we do implement MDIS as a base case where feasible. It's not always feasible. I have to be open, and that is often due to let's say the revision status or age of let's say the topside safety automation system, so that would require a major rework. So we are not always interested to do that, but in a larger scale, we are very much in support and continue to implement MDIS.
So there's a question that I will make a stab at answering, but others can also chime in. How many subsea equipment suppliers have adopted MDIS as their standard offering to date or have it in their plan? I don't think I can speak for subsea vendors. I do know only that there's at least 2 that have been certified already, so they have certified solutions. I also do know that there are most of the major subsea vendors are active in MDIS, and I believe they're working on solutions. But again, you should ask your subsea vendor of choice about MDIS and see what their answer is. I don't know if anybody wants to chime in more on that.
Yeah, well, from our perspective, I should say this comes down to, let's say, the availability of suppliers in the market, right? And from that perspective, we do see that we do have 3 subsea suppliers being in the position to deliver MDIS compliant solutions. I mean, they're cooperating with all 3, right? We worked specifically with Technical FMC on Snorre. We worked with OneSubsea on Snorre Bundle and Victus Boosting, and we worked with Arca Solutions on Johan Castberg. And we wouldn't have done that if they wouldn't have been in the position to deliver.
Okay. Has Siemens been successful in reusing software objects between vendors using MDIS without any modifications?
It have been a development journey for us. We have our software split into like the communication part, and that's have actually been very successfully. But on the object side, as this is different applications that have been used for, like Daniel also mentioned, the booster pump there. So there have been a few things that we had to adapt to and incorporate, and also due to this with some of the performance, we have had to scale down something. But in the big scale, we have managed to reuse a lot of software, and we hope to continue that path. It's always that, you know, this products are different, so we also have to adapt or think in that we can actually have to adapt software. But yeah, so yes, in the big run, we actually have reused the same communication, the same everything.
So I know there's actually some more questions out there, but we've already run over more than 10 minutes from our allotted time. If anybody has more questions, we will send email answers back, and as part of the recording package that we send out, we'll send you a written answer to all the questions that were posted. If you have more questions, please feel free to, you can email me, or you can email an MDIS. There's a contact on the MDIS pages too. And any of us will provide, we'll make sure that we answer all your questions. With that, thank you very much for attending. Thank you to our presenters, and we'll say goodbye.